yeah, I'm a PhD student at Edinburgh University, so when I came over here with the beautiful weather, I wasn't really prepared. I brought 3 woolly jumpers and no shorts. So yeah, I think I was expecting more of the same of Scotland. But it's really nice to be out in the sun. So my PhD is not about this stuff, it's about something completely different. So this is my hobby project. So it's really fun to be able to talk about my hobby project. So it's a C library called Cello. My talk is called Hacking C for Fun and Learning. So what is Cello? So Cello is a C library that adds these higher level programming constructs to C. So it uses a runtime system on top of standard C. And this makes many things possible that were previously awkward or really impractical to do. So this is things like generic data structures, polymorphic functions, interfaces, constructors, garbage collection, exceptions, reflections. So there's a whole bunch of cool things which can be added. And because it's just a C library, you can also use other C libraries and you get great performance and yeah, everything which is normal with C you get. So this is an example of a Cello program. So I think it probably looks quite surprising at first. So maybe it looks more like JavaScript or something like that. So we have this var, and then we have a $sign. So you can see first we're making some objects on the stack with this $sign, and then we make an array of these objects. So this is an array of integers. So already this is something you can't do in standard C. It's got no generic data structures. And then we're looping over these integers in the array using this for each construct. And then we're printing each one. And you can see we're using this format specifier, which is $. So this is like a generic format specifier. So what this means is just print out the object, whatever it is. So this is one other cool thing we can do in Cello. We can just print out anything. That's something you can't do in C. And you can see we also get the type of the object. So types are also objects which you can look at and manipulate and print and these sorts of things. And then finally, this array we allocated is destroyed automatically by the garbage collector. So normally in C, you'd have to manually delete this. So you get lots of nice things already. Here's another example. So here we created tuple, just a really basic collection. Again, we can iterate over it. We can use this range constructor. So this looks a bit like Python. We're like getting the length of it and iterating over the indices. And again, we can print them out. Or we can use this slice. So this is again a bit like Python, and we can iterate over every other item. So there's all of these new stuff, which is a lot like scripting languages. And that's the kind of stuff Cello adds. So now I'm going to talk a bit about some of the core ideas. So I apologize in advance to anyone who's not that familiar with C, because there's some horrible syntax which you're going to see, and it may be hard to follow, but I'll try my best. So the main idea behind Cello is about adding this polymorphism to C. So polymorphism is basically like how different objects or bits of data act under different operations. So it can be type classes or interfaces. It can be operator overloading, method overloading, duck typing, templates, inheritance, all these different ways. Languages have all sorts of ways of doing it. So here's some examples. Java and C#, you can do this something like class. Dog implements walk, so a dog can walk, maybe a human can walk, and a whole bunch of other things can walk. So walk is like a interface of different behaviors. So in Python, it's duck type, so you just do dog.walk and it walks. Haskell, again, it's like a type class, so it's instance dog walk, where in C++, you can do these templates, so they're like compile time polymorphism. You make a template function where the type is like agnostic. But in C, there's basically no way to do this. The compiler can't do this. There's no way to make a function work for many different types, at least not with the compiler. So We have to add it at runtime. So this is kind of what Cello is. It's like this runtime system which adds it. So lots of languages already do this. They have the concept of a vtable. So this is like a table of different functions for a particular object. So say you have a dog object, it would have a pointer to some vtable which would say how it walks. So it would have a function saying how to walk. And then if you have that, you can make these generic functions which look a bit like this. So if we have this walk function, maybe it returns the number of steps or something like that. It takes some object. You can get the vtable, and then you can call this walk function from the vtable. And this will mean the walk function is specific to whatever object was passed in. So this walk function, it does different things depending on what you give it, what object you give it. That's basically all polymorphism is. So we have these interfaces. So in Haskell, you write an interface a bit like this. So you say class walk A, where walk is a function which takes an A and produces an integer. And there's some other function. This is just a toy example. Walk2 is a function that takes an A and a point and produces an integer. So this is like a specification of different behaviors. And we can do something like this in C, right? So all we do is we make a structure with some function pointers in it. So you should remember this type def because that's going to be in the rest of the slide. So var just means some pointer to something, some object somewhere. It's just any kind of object. And then we have this structure with two function pointers. So this walk function and this walk2 function. So this is pretty similar to the Haskell specification. So then the idea is if we create an instance of this structure, that's like an instance of this type class or interface. So now we can think about making a vtable. So in Cello, the vtable is roughly like a null-terminated list of instances. So you can see this syntax. Probably it's a bit confusing, but basically this struct walk in brackets is like saying create a version of this structure called walk and pass in these two functions, dog walk and dog walk2. And then this ampersand is just taking the address. So this dog type is like the vtable for this dog. And it has a whole bunch of these instances of these type classes. And they're tagged with strings in this case, but you can tag them with other stuff too. Basically, you just want a big table of the different behaviors. So this is pretty horrible looking. So we use some macros to make it look a bit nicer. So now we have this dog type, and then this is just the vtable for this dog. So now it's quite easy to read. And so I've been saying it already, but in Cello, the vtable is just the type. So when I talk about the type of an object in Cello, I actually just mean it's vtable. So it's a list of different behaviors. Okay, so when we have this vtable, we can make a generic function like I showed at the beginning. So if we have some object, we get the type of the object, so we get its vtable. And then we find the instance of some type class in this table. So we can find this instance of walk in the table. And then if it exists and it implements the particular walk function, then we can call it. Otherwise, we can throw some error or something like that. So now we can do generic functions in C. So one of the really neat things about Cello is that we use this polymorphism, these interfaces for pretty much everything. So all the different high-level constructs are going to be using it in one way or another. So for example, these constructors and destructors, you saw there was a new function. There's also a del function. So actually, this is basically just like a type class. So you just give some functions to run when the object is created and when it's deleted. So you don't need some kind of special syntax or anything like C++. It's really just a type class. And we can also make these generic collections. So if we have an object, we can have a type class which says, what's the size of this object? So what's the size in bytes of this object? And then if we want to make a collection, of a particular type, we just find out the size, and then we know how much memory to allocate. So say we want a generic array, we can just allocate a huge block of memory with the right chunk size by getting the size of the individual objects. And then we also need some other class to say how to copy the objects into the collection. So we call this assign in Cello, but it's a bit like the copy constructor in C++. So basically it's just like how to copy the contents into something. We can also do iteration, so this for each is just a macro in Cello, but basically it just calls two functions. So one function is called iter_init, and it just returns the first item in some collection. And then there's iter_next, which just returns the next item in a collection. So again, these can work on kind of any object which can be iterated upon. So for iteration, again, we don't need anything special. We can just use these type classes. So even documentation. So you can think of documentation a bit like an interface, but for types. So we saw that types are also objects in Cello. So when you call something like name or description, this is like just asking for a particular instance of this type class for documentation. And it will just return some strings. So this is quite nice because it means we can get documentation at runtime a bit like Python. We can just call help and call it on some object, and we get all the information about it. And even the garbage collector uses it a bit. So if there's some object which does custom memory allocation in some way, we can get it to implement some special type class to tell the garbage collector, oh, also go and look at all of this memory to see if there's any objects there. So pretty much everything in Cello is making use of this. And there's no other features like inheritance or anything else. So this is pretty neat, I think. So the question is how to implement this type of function, right? So here I said we want to get the type of an object, but I kind of glossed over how we actually get the Vtable. So in this case, self is just some random pointer. So now we want to know how do we actually get the Vtable for this pointer? Like what type is it at runtime? So we use this idea of fat pointers. So this was like an idea proposed by Walter Bright, who made the D programming language to solve problems with C. So one of the major issues with C is that when you pass an array to a function, it decays to a pointer. So what you actually end up passing is just a pointer to the first element in the array. And this means that you don't have the length information anymore. So you don't know how many items are in the array. So this is like famously caused many, many problems in C. For example, strings in C have to be terminated with this null character because you don't know how many characters there are. Or other arrays, you have to pass in the length separately. And programmers or malicious users, they make mistakes or give wrong values, and this causes serious problems. So lots of the security problems are due to this. So the proposal was basically like you can add a new type of pointer to C, which is called a fat pointer. So a fat pointer is compatible with a normal pointer. So if a function just expects a normal pointer, the fat pointer just becomes one. But if the function expects this fat pointer, then it's past that. And the fat pointer also contains extra information, like how many items are in the array, for example. So this was proposed as a C extension. But actually, you don't need to do it with a C extension. You can do a kind of little trick to emulate it. So what you do is, when you allocate an array, you allocate a little bit of extra memory at the top. And in this memory, you put the length of the array. And then what you actually give to people is this offset one. So this offset one points to the first item in the array. So then if you need the length, you just step back in memory one and access it. Otherwise, you just pass around the pointer as normal. So this is actually used by more than just me. So the author of Redis, he has a strings library which uses this exact trick. So yeah, it's quite interesting. So then if we have something like this, in Cello, instead of the length, we can put this type, so just a pointer to the Vtable. So then if we want to get the type of an object, we step back in memory, so that's this little bit of pointer arithmetic, and then we return the type. So now we can really easily get the type of an object. So this means we need new functions for allocating and deallocating objects, right? So we need to allocate this little bit extra at the top. Okay. So on the heap, this is pretty straightforward. We just allocate, we just add the size of the header to the amount we want to allocate. And we set the type, we set the Vtable, and then we just do the pointer arithmetic, add the offset again, and we're done. And to deallocate, we need to do the similar thing, so we need to just step back in memory. So here we just step back the size of the header and free that, so free the actual thing we allocated. So we can also do it on the stack. So we can also allocate these fat pointers on the stack. So we just allocate an array of characters, which is the size of the header plus the size of whatever structure we want to allocate. And then we pass it to this header init function, which just sets the type and adds this offset. So this is kind of useful because now we can have these fat pointers, but they're living on the stack, so they're going to get cleaned up automatically when the function ends. So you saw this dollar symbol in the examples. So this is basically how we do this allocation on the stack. So we do this previous macro to allocate some amount on the stack, and we just copy in some structure, right? So it's just some C literal structure. So this is kind of a fun hack because this is not really an allowed token in C, but lots of old systems used it for different weird reasons and different special purposes. So almost all the compilers support it. So it's probably not a very clever thing to do, but I think it's fun. And then we can allocate these objects on the stack without worrying about deallocating them. So this is a bit like we can make these boxed objects very, very easily in Cello. So this is what makes it much nicer to use than lots of other people who've done similar things. So you can think that this is a bit like Java or something. You have the capital ones, which are like the boxed versions. So in Cello, we can create like a boxed one really easily. And so the other neat thing is that these kind of fat pointers, they're just the same as normal C pointers because the thing we actually pass around is the same as the normal pointer. So we can cast them to C pointers, and then we get the type safety. So I was using var a lot before, but you don't actually need to use this. You can use the C type system where you want. It's not a problem. And you can pass them to functions which just expect normal C structures, and you can access their members and all of these different things. So basically, you don't have much to lose by making these objects into fat pointers and having this extra bit of information at the beginning. So this was the first example I showed again. So maybe it will make a little bit more sense now. So here we have the dollar, and we're creating some integers on the stack. So basically this is allocating a little bit of space for an integer and also a little bit of space for this pointer to the Vtable. So this int is just a Vtable for an integer type, so it says all the different behaviors of an integer. And then we're just getting pointers to them here. And so now we create an array, and this array object is again just a type, it's just a Vtable. So this new function looks at this array Vtable to see how to construct an array. And then it looks at this int type to see the size of an integer. So then it can know to allocate enough memory and copy in all the integers. And then we loop over them, and this format specifier, it looks at some show type class to say how to show different objects. And then at the end, the garbage collector gets rid of them. So there's lots of other fun stuff. So I don't have time, but there's the garbage collection, exceptions, there's some fun performance optimizations. And also one really nice thing is when you have this runtime, you can add a bunch of runtime checks. So you can check if memory allocations fail, or if array out of bounds, or if things are going to go invalid. So you can actually make lots of things a lot safer than normal C. So now I want to talk a little bit about why Cello exists. So I think lots of people see Cello and they think, why not use C++, or why not use a proper language with all these features? I think that's probably a fair point. I guess the mantra of this conference has been something like use the right tool for the right job. I think Cello is like the wrong tool for the wrong job. So now I'm going to convince you of the complete opposite of everyone else. So C is, I think it's about hacking. So hacking is when you do something for what it isn't intended, or you do something creative or playful or intellectual. So I think hacking and hacking culture is really important. So first of all, hacking is a very positive ideology. So it says, what's cool, what's great, rather than saying, what's dumb and what you shouldn't do. It even says you shouldn't tell people what they shouldn't do on their computer. I think that's really important because there's a lot of negativity in software engineering. There's lots of people saying this is dumb, some idiot made this library, who programmed this piece of shit or whatever. And also hacking glorifies, what's fun and sharing with people. So I think if you imagine hackers playing a board game or something, probably they don't want to win, they just want to do something dumb or do something quirky and have a lot of fun with other people. So lots of people spend their life, trying to beat other people or be the best. And I think sometimes it's better to just step back. And then finally, hacking doesn't value people based on race or background or authority. So I think this is really important if you want a meritocracy. So you want to value people based on what they've done and what they give and how they interact with you. So I think hacking culture in general is pretty important. So fun. So I think Cello is pretty fun. There's an old English playwright called Noel Coward, and he has this quote, work is more fun than fun. And what he means by this is, for him, when he's writing these plays and working with these creative people, it's more fun than just going down to the pub in the evening with his friends and getting drunk. It's more fulfilling, and he just loves doing it, basically. So I think this is achievable in programming too. So I think programming is really about self-expression, and you can't really express yourself properly if you're working on other people's terms or ideas. So you really need to have conviction in what you do and believe it yourself. And then I think you can have these projects which are more fun than fun. So you can have these creative projects which you care about, and you get to make all the decisions and express yourself. And I think these are really great. So I had a lot of fun making Cello anyway. So learning. So I think there are too many problems in the world, and there's loads of people working on them. So the low-hanging fruit is gone. You can't just become a famous genius straight away and solve all the world's problems. And so if you have these large problems, which are too large, they seem completely insurmountable. So these are things like, solving world hunger or something like that. So it's kind of hard to get motivated for these problems because they seem too big. You don't know how you're going to approach them. And then some problems seem too small. Maybe something like cleaning your desk or something. You don't really care. You don't really want to do it. Again, it's hard to get motivated. So I think it's good to add these artificial constraints because they make problems more specific. So if you think about maybe just trying to solve hunger in your town or something, so no one goes hungry in your town, you can start thinking about how it might work, talking to the council, talking to supermarkets, charities, these sorts of things. Or cleaning your desk even, you can say, I want to clean my desk, but I only want to move 3 items, right? So if you play this game a lot, probably you actually learn something interesting. Maybe these bin packing problems or something, I don't know. But you learn something about something because you've made it more specific. You've made it harder, basically. So the world hunger one you made easier, this desk one you made harder, by adding these artificial constraints. So yeah, you can be more innovative and gain insights to bigger problems. So I think Cello is a bit like this. Basically, I've done it in C, and it's these artificial constraints. I could have just used any other language. So I think it's good to do these sorts of projects. exploration. So the Earth has been like pretty much totally explored. So long gone are the days where you can travel to a different country and see a creature no one has seen before or something like that. But because we're programmers, we have these mathematical worlds, so we can explore these instead. So we can look at these different languages and build new things. So I imagine this is like a series of interconnected caves. So maybe there's like a C cave and a Java cave and all these passages leading out which people are exploring. So yeah, many programmers are just going in these caves which other people know well. They're like they're just learning new languages or technologies which other people have looked at. And lots of other people are pushing down to find new stuff, so they're building new languages or new research projects. And both of these are pretty important. But I think Cello is like a little bit different. So it's more like you're in one of the main caves and then you find some passage and you follow it down and then it opens up and there's all this new cool stuff. So I'm not like certain why this is important, but I think this kind of exploration should be important for some reason. Maybe it challenges people's assumptions about existing things. So yeah, I think projects like Cello are important for that reason because you get to explore these areas. So finally, quickly, I want to talk about why I think people think Cello is exciting. So basically, it's a library which changes the host language almost completely. So JavaScript programmers probably know about this because it was pretty dead language, and then things like jQuery and underscore, and then a million frameworks came along, and suddenly everyone wants to use it. It's totally new. It feels fresh. So maybe this is a bit like Cello. So it's just one design of this sort of runtime library, but there could be many more. So maybe there'll be something like that for C. I don't really think it will be the case, but maybe that's why people think it's interesting. Okay, so that's all. Thank you very much for listening. Yep. A type error looks like, well, actually, it's quite good. So it is a runtime type error if it's one of these polymorphic functions, but it will spit you out a stack trace and these sorts of things. So that's one of the nice things about the runtime is you can get a bit more information, and it's not just a segfault, so that's pretty good.
Will the standard pointer arithmetic works with this?
Yep, it works fine. So this is all pretty portable. So even the garbage collector is portable, so it should run on anything you want. Maybe not embedded systems because there's quite a lot of code. So people have said it doesn't fit, but yeah.
I'm a bit curious about the comparison to GTK's glib, which does some similar tricks in terms of an object system on the C language, and to Objective-C, which is a kind of minimal-ish set of additions to the language to get us what I think is a similar object structure. I was wondering if you had thought about Cello in relation to either or both of those.
Yeah, so it's very similar. The older version was probably more similar, but it's very similar to if you've ever done some interface between scripting and C. The actual scripting language when you're programming it in C is quite a lot like Cello, but usually with horrible syntax. So Cello is kind of just like it's sort of like a syntax hack on these sorts of ideas. Yeah, so it's very similar, lots of very similar ideas.
Hi. What kind of GC are you using? Is it just a mark and sweep garbage collector, or?
Yeah, it's just mark and sweep. It's pretty basic. I wrote it myself. I don't have any real experience in the area, but it seems to work. I benchmarked it. The performance is surprisingly good. Yeah, I'm quite happy with it. But yeah.
Are you planning to make it like swappable with something? Like somebody would write a separate GC mechanism and plug it in.
Yeah, it should be perfectly possible to do that, and like I said, it's optional, so you can stop and start it and just use it for certain objects, or even just certain parts of the stack, right? So you can like just enable it for a little bit of the stack or something like that. Okay, thank you very much.